Let's talk for just a second about what each of these things happens to be. This is a proton and this is a hydroxide. This sort of idea here about what these protons and hydroxides are come out of acid-base theory. And although we don't spend much time talking about acid-base theory in this course, there are in fact three different kinds of acid-base theories that you're introduced to. You're introduced to the idea of an Arrhenius acid. You're introduced to the idea of a Bronsted acid. You're introduced to the idea of a Lewis acid. And then we have the corresponding bases. An Arrhenius acid is one that simply says that this proton right here in the form of a hydronium ion is an acid. So that one's nice and simple to understand. So you've got a hydronium ion, you've got a hydroxide ion, and the two of them can combine to make water. There's a second kind of acid called a Bronsted acid, in which you have this proton coming from some source, but it doesn't have to be water. It can come from acetic acid, it can come from formic acid, it can come from hydrochloric acid. And a Bronsted acid is something that donates protons to a system. And then you have Lewis acids and bases, which are built upon the idea that an electron pair is a Lewis base. So any compound that has an unattached an unattached electron pair serves as a Lewis base. Ammonia with that dot dot sitting on top of it being an example. And then a Lewis acid is anything which is attracted to that dot dot, and that turns out to be something like an empty orbital. But regardless of whether or not we're talking about Arrhenius acids and bases, Bronsted acids and bases, or Lewis acids and bases, in the end, the way that we have a sense of having measured something associated with whether you have acids or bases in solutions revolves around counting these sorts of things here. Being able to look into this bucket and to ask yourself, how many of these things are in here? How many protons are in here for this particular volume that I have? Well, you can see right away as we do this problem that if I only have water sitting in the solution and I've added nothing else, if I have a pure solution of water, the answer to the question of how many protons I have in solution is going to have two results. One, you're going to have exactly the same number of hydroxides because of stoichiometry. For every one of these that's made, one of these is made. So if I've got 3 protons in solution, then I've got 3 hydroxides. And in this lecture, that's all we're concerned about. Let's just make darn sure that we have pure water, and then I don't know how many protons I'm making, but it's equal to the number of hydroxides.